everyone, welcome to the lecture of week 11 summary and assignment. So, in this particular lecture we have primarily talked about emerging trends and advanced tools. We have started with integration of GIS with AI techniques. We have started with some sort of more technical advanced tools. We have started with some sort of ecosystem based services like that. So, this is we have discussed in this class. Now, in this particular lecture we will primarily summarize whatever we have covered in this particular week. So, we have started with emergence of the big data in climate science. What is big data? It would be high volume, high velocity, high variety data set which is relevant to the climate science. Why? It basically enables analysis for long term high resolution data set, and if you have a long term high resolution data set, we can tell you about more variability in the system and more process interpretations. What could be the data source? It could be it could be a satellite, it could be reanalysis product, it could be sensor network, it could be citizen science data set. These are the source of the data set which can club it together, can inform a big data in the climate science. So, for example, you can take a data from satellite which is basically part of atmosphere, land, ocean measurement. We can take about the data set from reanalysis product which is historical weather data and which can also tell about climate models data. Citizen science data which is basically tell about the public contribution, public opinion, valuable contribution, valuable informations like that. If there is a sensor network, we can tell about weather stations, ocean buoys. If you integrate it together, it can be formed as a big data in climate science where you have high volume, high velocity and high variety data set. So, what is the analytical tools and techniques which we can use and which are advancing that can give us more insight about climate extreme analysis. For example, we can talk about machine learning and artificial intelligence which are improving the predictive modeling, and we have got a very good precision of accuracies of predictive modeling in variety of the fields of climate science. Pattern recognitions, anomaly detections like that, so that we are able to do some sort of these tasks very efficiently because of the machine learning and AI. Cloud computing and HPC, now we have started using large data set because we have access to cloud computing and high performance computer. For example, if you talk about Google Earth Engine, Amazon services like that, or maybe you can talk about geospatial analysis. You have started now, there are lots of studies are focusing on the global areas. Now we are more because of the access to the large data set, global data set, more efficient programmings and this cloud computing and geospatial analysis softwares has made this possible that we would be able to do some sort of very broad scale analysis and do some sort of process interpretation, visualization, spatial correlations like that. So, for example, if you mix the machine learning with the cloud computing, you are able to do some sort of more better predictive data processing. If you are mixing with the machine learning advanced tools with your geospatial advancement, you would be able to do some sort of spatial predictive modeling. When you are mixing with the geospatial analysis with the cloud computing, you would be able to do more efficiently the spatial data processing that will help us to understand the pattern or anomaly or the series of time or spatial data set more efficiently and can correlate with your different sets of processes which you are hypothesized that okay, these are the processes which are responsible for climate extremes. So, this kind of the analysis can be done by advancement of these different techniques and continuously evolving. Therefore, you have more and more informations are coming as the techniques are advancing. Heat wave, for example, this is example of heat wave prediction using AI. Now, you can see that this is the historical observed data set, and LSTM kind of the network deep learning algorithms can train the historical climate data, daily maximum temperature, and then basically it would be able to possible that we can tell about how the heat wave is likely to behave in next few years, 3-4 years like that. So, based on this accuracy and all, we would be able to prepare well with our futuristic steps, so that it will enable us to protect from the climatic extremes conditions like that. So, this is an example of how the deep learning algorithms can be very useful for heat wave predictions. So, this is another example how we can use cloud platform, for example Google Earth Engine, to model the flood inundation across a very bigger region, and we can tell about what is those regions which are frequently affected by floodings. So, that is basically we can do some sort of real time flood detection using satellite imagery that can be used by cloud platform, that is Google Earth Engine, and that uses basically very high resolution flood extent mapping for disaster response like that. So, you have the data set, you can basically have the access to the cloud platform, you have processing tools are available with you, and you have to just implement that analysis on the real time analysis data set, and you can tell about to the disaster response team, or to the policy makers, or to the local stakeholders, that okay, this area is likely to be flooded or has been already flooded, and these people have been already stuck there like that. So, these information can be revealed when you have fine resolution cloud computing and efficient modeling methods which are available in our fingertips, and that can be done about lots of more information about climatic extremes. Then there is a how do we introduce AI in the climate science? We have talked about we can tell about use of the machine learning and deep learning for the climate data set. We can do some sort of pattern recognition, we can do classification, anomaly detection, we can handle a very high amount of high dimensionality of the data set. We can also talk about non-linear detection of the data very efficiently. For example, we can collect the data and analyze, we can look at the reanalysis product, we can look at the observational data set, we can do some sort of detrending, denoising, gap filling those information. Then you can start using that data into AI methodologies. It could be modeling, it could be understanding, it could be integrations like that, and then you can start looking at the predictions, for example attributions like that, or patterns and trends like that, or causal relationship like that. So, this kind of the information can tell you about lots of more details about what is the overall patterns of the climatic extremes, how the different variables are influencing your climatic extremes, what is their relationship has been evolved through the time. So, these are the information we will be able to get that. So, this is the some of the example which we have already discussed in the previous class, that remote sensing application in the climate extremes. We can use the synthetic aperture radar data, this is radar. So, data for real time flood extent mapping. So, what is why we are using radar? Because radar is a kind of a direct remote sensing approach, active remote sensing, where we are not relying upon a secondary source, and there is a source which are already inbuilt in the satellite system, and therefore, during the cloud cover or during the that situation when we have higher cloud cover, we will not be able to look at or correctly assess the secondary radiations, secondary source radiations which is coming, interacting with the earth's surface and coming back to the satellite. So, that problem has been solved by the synthetic aperture radar kind of data. Now, we will be able to see through the cloud, we can look at those areas where we have higher flooding potential during the monsoon months and all. So, that is basically the advantage of flood detection when we are using the SAR data for real time flood extent mapping. We can use heat wave surveillance, we can use thermal infrared data set imagery for surface temperature mapping, and that will tell us about how the different region has been behaving in extreme temperature, which area is more prone to urban heat island effect, for example, or which area is highly rising the the temperature of surface air temperature. So that can be done by using the remote sensing as well, and that because if you are implementing the remote sensing data set, we would be able to map a very large area when we are using some sort of thermal infrared bands like that. We can also calculate the drought monitoring using some sort of NDVI or land surface temperature with MODIS. We can integrate, so these are the indexes or the land surface temperature are also derived from some sort of thermal bands, or NDVI is also derived from different band combinations. So we can use these kind of index or land surface properties and integrate together, and then we can look at how the drought has been changing the behavior of one particular region, how it has been evolved, how it has been interacting with other kind of phenomena like plant growth or vegetation cover or crop yield like that. You can also use remote sensing data set for cyclone tracking. So there are lots of satellite which are covering a broader region and can tell us about where the cyclones are currently positioning. So therefore, when we have the information of real time information, you can plot it together in the historical time period images, and you can track down that which path a cyclone is actually following, and you can correlate with your modeled result, and then you can basically fine tune your model using that real time observations of the satellite data set, and you can forecast which area or which coast is likely to be impacted by more significantly by a cyclone or landfall or something like that. So this is how basically we can do a remote sensing application in extreme events detections like that. There are AI techniques for extreme events detection. For example, you can use supervised learning, random forest and all. You can also use unsupervised learning, which are k-means and clustering, hierarchical density based clustering like that, dimensionality reductions like that. Then you can use deep learning algorithms. There are ANN, CNN, RNN, RBM like that. So many deep learning algorithms are developed, and based on their requirement, for example, if you are interested in some sort of time series analysis, you are more interested in LSTM. Okay, so let's say if you are interested in doing some analysis with the images, remote sensing images, you are interested in applying GANs. Okay, so this is generative adversarial networks, for example. So these kind of the systems are there, the deep learning models are there, and you can use these models to basically predict overall how the pattern has been changed like that. In the next lecture in this week, we have primarily talked about ecosystem and climate resilience, because ecosystem is also plays a very critical role in mitigating the negative consequences of the climate extremes. So ecosystem provides multiple services to climate extremes. For example, it provides supporting services which are soil formation, primary production, nutrients recycling, or water cycling, or biodiversities like that. It is also kind of a provisioning services which are basically water supply, food production, timber energy, genetic diversity and all. It also provides some sort of cultural services which are basically recreational and tourism services, cultural heritage, tranquility and inspirational or spiritual values, for example. And it is also provides some sort of regulating services, air quality, climate and carbon sequestration, storage, water flow and flood, erosion, soil quality, water quality, disease and pest and pollinations like that. So these kind of the services are provided by the ecosystem. So suppose if we do not have the ecosystem in those areas where we are having a more frequent extreme events, it is likely that those events will be further amplified. And once it is amplified, we may have end up in the irreversible conditions of position where if we do some sort of action towards the climate extremes as well, we might not able to get back to the original positions like that. So that is basically the importance of ecosystem in mitigating the climate extremes like that. How do we do that? Ecosystem based adaptation is very important. Use of the biodiversity and ecosystem services as a part of adaptation strategy. community involvement, sustainability and co-benefits, and it is basically a low cost, scalable co-benefits for biodiversity and livelihood. So, we need to have some sort of system knowledge, ecological structure, urban trees, wetlands, green roofs, etc., ecological functioning and the processes, how wetlands provides, let us say, flood protection. Then there is the adaptation benefits, where we should have some sort of normative knowledge or let us say valuation of that particular ecosystem there. And then you can have some sort of transformative knowledge, where we have to know about direct or indirect actions that modify ecological structures there. So, this is basically we have to look at very carefully when we are dealing with the ecosystem services in context of the climatic extreme. So, this is the one example we discussed about, where we have a mangrove forest and there is a storm and surges and floods are coming in the coastal area, and if you remove that mangrove forest, it is likely that these floods will be very violent and that will basically encroach or infiltrate inside the coastal region and can affect the urban populations there. It is kind of a mangrove forest are providing some sort of shelters, some sort of reducing the velocity and barriers, and therefore it is very important to have those biodiversity regions near to the coastal regions, so that we can save from the storm surges or floods without much losses if we do not have that like that. So, this is basically we have talked about in the previous lectures like that. So, okay, so this is all about we have discussed. So, we have discussed started from very intense discussion on advanced technologies on AI and remote sensing. We have then talked about how we can integrate the remote sensing data set with your climatic extremes analysis and all. Then we have also discussed about how do we use that ecosystem services to amplify our mitigations or strategies in a one particular locations, where we have done some sort of climate extremes analysis more more frequent is like that. Now, how do we do that these analysis? So, in this assignment we can just go through the platform of Google Earth Engine, and we can understand about how the cloud computing is actually working, how we can use the concept of cloud computing in our day-to-day application of this climate extreme analysis, and how do we leverage, let us say, the also the available tools in that Google Earth Engine that can help us to do some sort of very advanced analysis using the data set which are stored there. So, we do not have to download the data in our local machine. So, it is data in the cloud. You have to call the data, you have to name, there are names are there, technical names, and you have to call those data set, you have to store the data set in variable, and then you do that analysis. For example, if you are interested in flood analysis, you can call the synthetic aperture radar data for one particular region, and then you start gap filling or spatial imputation and spatial interpolation like that. Once it is done, then you basically look at different indexes that can tell you about which area is water area, which area is non-water area. Once it is done, then you can do some sort of temporal multiple temporal analysis, and then you can aggregate it together, and then you can tell about which pixel has more frequency of water area, which pixel have the more frequency of non-water area, or which pixel has a mixed frequency of the water and non-water areas. Based on this, you can calculate what is the frequencies, probability of occurrence of the water pixel in different areas like that. Wherever you have higher probability, it is likely that here the water will always comes. Higher probability is that. When there is a low variability probability, that is possible that whenever you have a high flood conditions, water can come also in this particular region like that. So, this kind of the analysis will tell you a lot more sense of the regional pattern of the floods, how the floods are evolving. Let us suppose you can do this analysis by clubbing it together with let us say land use land cover data set. Okay. So, using the land use land cover data set, you can tell about how the people or urban area has been expanded near to the river where we have frequent floodings are coming, or let us say within 5 years, last 5 years, it has been seen that this area is now reported on more in a inundation area or more frequent water area, water inundated area in the frequent area. So, this is kind of the information you can do that by using the analysis using these kind of the cloud platform, and can analyze the a particular region, and then you can also make some sort of zonation out of this. So, in the next lecture we will primarily talk about how do we use this Google Earth Engine. We will first go through the Google Earth Engine platform, and then we will discuss about how we can play with the Google Earth Engine platform. We will also discuss about what kind of the data sets which are stored in the Google Earth Engine, and then we will also discuss about how do we call that data, for example, and then you can look at different data set as well. So, this is basically one kind of assignment. You can also look at it, and we will discuss in the next class as well. So, thank you so much for your attention. In the next lecture, we will primarily talk about whatever we have given this assignment, that is Google Earth Engine Cloud Platform, and you can deal with it. And then we will discuss about this and how we can we will discuss further on the Google Earth Engine in the next class as well. Thank you so much for your listening.